Cute. Good news. You have a quiz on Thursday. There's 3 problems. The first problem is one of these. Pythagorean identity type where you actually have to be tan this time. So let's do that. The second problem is a sine and cosine wave equation, graph it. And the third problem is a permutation or combination. So, we have those from the from Friday. But let's start with this. You find tan and cosine if sine is negative 2/3. Okay, so if sine is negative 2/3, that means that the y is negative. And cosine is less than 0. That means that x is negative. And that means quadrant 3. So I'm going to draw myself a little quadrant 3 over here. Yeah, a decent triangle for a Monday. Okay, now it says sine is negative 2/3, so that's going to go on the height, except for that that's supposed to be a 2. Negative 2/3. And that's what we're solving for, and the hypotenuse is 1. X squared plus negative 2/3 squared equals 1 squared. X squared plus, what is negative 2/3 squared? 4/9. Nice. Okay, why did I make 1 into 9/9? Nice. Will, are you okay, honey? Square root. And I'm going to come up here. X equals plus or minus. Okay, and I have square root of 5 because that does not come out evenly, but 9 does. Okay, and then the last step is to decide if I want the positive or negative. And it's quadrant 3, and I already determined that cosine should be negative, so I want the negative one. Okay, any questions about how I got cosine? You sure? Okay, now we're going to do tangent. Tan is y over x. Y is right here. We're 5 minutes in. I'm already irritated, just so you know. Good job, though. Good job. Threes cancel. And the negatives also cancel. And I have 2 over root 5. Okay, then what? What's it called? Rationalizing the denominator. 2 root 5 over 5. Okay, do you guys see where I got 2 root 5 over 5 from? So 2 root 5, and then those two guys multiply together to get 5. Okay, can you do this? Can you do this all the way? The whole thing? All right, scroll down to number 3. We have a lot of practice at this, but we need more practice with negatives. Notice that I put negatives on all of these on purpose. So this is still 0. This is negative 90, negative 180. I'm going to put a little arrow there so that I can make sure I understand the way I'm rotating for a negative. Okay, so here's 0. Here's negative 90. So negative 1/10 is going to be right about here. And the reference angle is 180 minus 110, which is 70. Notice I ignored the negatives. Just thought about them as positions instead of direction for a moment. It makes the math so much easier. Okay, now it says find the positive angles with that reference angle in all 4 quadrants. So the easiest way to do that is to take your ruler and extend the lines out into the other quadrants. And this is why we use the word coterminal. This is positive 90. This is also positive 180. Positive 270. Positive 360. It's also negative 360. Okay, so if this is 70, what's this? 70. What's this? What's this as a positive? 250. And what's this? 290. Okay, positive and negative coterminal. Negative 110 plus 360 is 250. Oh, look, our visual confirms that that's the case. Negative coterminal would be negative 470. With negatives, is this getting better? I hope. Okay, I believe, no, we're not done with the packet. If you guys could please find the digital escape sheet from the weekend. Okay, finding a paper doesn't mean you need to talk about it. Do you have any that you got stuck on that you'd like me to go over? Yes, hold on. 8. Okay. 8 says, oh, eight's tricky. Okay. So it says there are 13 girls and 15 boys in class. A group of 12 students needs to be selected for a school committee. First, can I tell you, committee, they're all the same level. So they're treated as all the same, which means that it's a combination. And then it says, since all the students are interested, the teacher decides to select the students at random. That means that you need to combine this into one class. So it's 28 combination 12, which is a really big number, by the way. Next one. Want me to go over any others? Yes, Moses. I think number 9's the hardest one on the whole thing, just so you know. To be honest, I had to like use pens to be able to do it myself. Okay, so I'm going to explain it to you with pens, but I'm going to read it to you first. It says, a drama teacher needs to arrange 6 students in a line so that 2 of the students are always next to each other. How many ways can this be accomplished? Okay, so what I did was I grabbed 6 different color pens and I said, okay, here's my 6 students in a line, right? But these 2 right here are have to be together. So I literally went like this. Okay, so do you see that this really limits me down to 5 options now instead of 6? Okay, so I want to know how many different ways to arrange 5 pens out of 5 pens. Okay, and so that is 5 permutation 5. Okay, so I started with that 5 permutation 5 because I taped these 2 together. So that means that there's actually only 5 options. However, pretend this is Moises and Brendan, okay? It could go like this, or it could be Brendan Moises. So you have to take all of your options out of your 5 and multiply it by 2 because you don't know which side Brendan is on and which side Moises is on. Okay, now let me show you how Mr. Knight explained it to me. He went like this. I appreciate Mr. Knight. Okay, here we go. Are you ready? It's going to be great, I promise, if I can just space them properly. Okay, he went like this. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. And then he said, or they could be here. 1, 2, 3, 4, 5. Or flip. 1, 2, 3, 4, 5. So there's your 5 permutation 5, but every time you get the flip, then you have to multiply it by 2. Pens. Even the teacher needed pens. And 3 teachers to talk about it most of lunch last Friday. Anyway, I think those are 2 of the spiciest ones. Anything else you want to go over? Okay. You guys could please find this in your notebook. Yeah. You are done with the package. Just note that your homework is the quiz review. There's 2 Pythagorean identities, 4 sine and cosinoids, and 2 permutation combinations. It depends on if your class makes me, interrupts me about 57 times. Okay. So I promised you that I would start out this lesson with a history lesson, and it's true, I am, but I want to remind you, we were talking about Angela's savings from her uncle Zachary. He had, put in $50 the first month and $53 the second month and saved money all the way till she was 18 years old. So that ended up being 216 months of savings. And we determined that he was a super cool dude and that Mrs. Salva didn't have anybody like that. And that I had to sail down the road of student loans. Yeah. Okay, anyway. So I want to talk to you about Gauss. Gauss, I want to show you a picture of him. He was born in 1777. I have a photo so you can visualize the man. There he is. Okay. And he was a genius, a child genius, but he was also extremely naughty. So when I get irritated with your class, whatever he did was like times a million worse. Yeah. He would irritate, he's one of those kids who would finish their work super early and then just irritate everyone. Okay, so the teacher said, which I'm assuming was a dude because it's 1780s, said, I know what, I'm gonna keep this kid busy for a while. I'm gonna tell him to add up the numbers 1 through 100. And this guy was such a genius that he went back to his table desk school with his tablet, quill. I don't know what stuff they used in the 1700s. It's the only part I don't know about this story. Anyway, and he wrote some stuff for like 10 seconds and then came back up to the teacher with the answer. Okay, and this is what he did. He said that if you want to add up the numbers 1 through 100, you can list them like this. And what you can do to make this easier on yourself is list them again backwards underneath. And then add all of the columns together. So he listed the numbers 1 through 100 forwards, and he listed the numbers 1 through 100 backwards right underneath. Now, what does this column come out to right here? 101. What about this column? 101. What about this column? 101. And what about this last column? 101. Okay, so Gauss said, all right, if I want to find the numbers 1 through 100, the sum, I just say, okay, I have 101 times 100 because there's 100 columns. Can you guys all see that there would be 100 columns if I wasn't too lazy to write them out? Okay, but however, I have to divide that by 2 because I wrote it twice and discovered the formula for summing any kind of arithmetic sequence. You can add any kind of arithmetic sequence using this method that Gauss discovered for us in probably like 1785, which is amazing. Okay, so what we're going to do is write his formula, and then we're going to use that formula to find Angela's savings. Okay, so this is how we use it today. We say n over 2 T1 plus Tn. N is the number of terms. This is term 1. And this is term n, which is usually the last term. Formula back to what Gauss did on his tablet chalkboard. Tablet. I'm sure it wasn't tablet. I just say that one because it's fun to say. Okay. So I want to take this and match it to the formula we used today. So in Gauss's problem that his teacher gave him, there were 100 terms. So this is 100 over 2. That's this whole part of it right here. And then the first term was 1, and the last term was 100. When you add them together, you get 101, which is this little bit right there. Okay. So now we're going to use the formula to find out how much Uncle Zachary saved for Angela. Okay, I'm going to ask you guys some questions. You're going to have to go back into problem number 1 to look for the answers. How many months did Uncle Zachary save for Angela? 216 over 2. And what was the first amount that Uncle Zachary deposited for Angela? 50. And what was the very last amount? $695. It says it right here. In the final month of her 18th year, 690. Okay, so calculator. This is very easy. You can just go 216 divided by 2, and then parenthesis 50 plus 695. So without any interest, he saved for her $80,460. It's pretty great. Where was this guy when I was going to college? Okay. Number 4. Okay, so just to warn you, 10, 4, and 5 are going to be extremely easy. 10, 6 is 5. So don't just get all like complacent because you think it's simple. It is simple at first. That's the way math chapters go. Easy in the first couple parts and then bam, they hit you with something. Okay. So the first thing we're going to do on number 4 is we're going to practice writing the equation. We're going to write it both ways. We're going to write it in terms of term 0 and term 1. Okay. T of n equals. What is the growth in this problem? Plus 2. 2n. And what would term 0 be? -1. Okay, that's how you write it for term 0. That's how you wrote it in Math 1. That's how we wrote it in our warm-ups before. Now we're going to do the new one, which is writing it in terms of the first term. So you start with T of n equals 2, just like you did before. But instead of n, you write n minus 1 and then add the first term. I like that one better because I'm lazy and I don't want to figure out what term 0 is ever. But they both work. It's whatever one you like is better. Okay. So what I've concluded is there's only one table that has an issue with this. Okay. Now, I wrote it all out again, added up, because I want to go over the vocab. The very first original problem with the commas, that's called a sequence. Sequences have commas. Okay. In B, I took all of the numbers in the sequence and added them together. That's called a series. Series have answers, which is a sum when you add them together. Okay, so sequences have commas, series have pluses, and there's an actual answer to the series. Okay, can you trust my math that my series comes out to be 36? Okay. Now we're going to look at this problem visually. I want you guys to look at this. Let me see if I can just isolate this image. Okay. Some people are great with formulas, other people are great with visuals. I want to make sure that I account for both in this lesson. Here is a graph of the sequence that you guys just wrote down. This is 1 plus 3 plus 5 plus 7 plus 9 plus 11. Do you see it? Yeah. Okay, now, do you see where it says on your paper terms? Oh, okay. The terms are the height of the bars. After the word terms, write the height of the bars. The height of the bars are the terms. Meaning 1, 3, 5, 7, 9, and 11. Okay, now where it says series is the area of the diagram. The series is the area, meaning that they're all the number of boxes added together. Okay, I'm going to come back to that picture in just a second. Okay. I want you guys to imagine playing Tetris. Okay, imagine that you're playing Tetris. Kind of. I'm not going to Tetris works. Can you imagine me taking this whole graph, flipping it over, and setting it right on top of here? Okay, so you take this graph, flip it over, and set it right on top of here. That's kind of what Gauss is saying. He's saying that if I can have two of these, I can fit them together to make a rectangle. Okay, now pretend that this is flipped over and it's now a rectangle and there's two pictures. What would the base of the rectangle be? 6. Okay, next to D on your paper, write 6 times. Okay. Now, this is the hard part. What would the height be? 12. Right, 6 times 12. And then divide it by 2 because you have 2 diagrams. Okay. Proving to you that Gauss's formula works on a very easy diagram. Okay, so now we're going to go to slightly more difficult diagrams. They're actually still easy. I don't know why I said that. This problem is very easy. Number 6 is where it gets spicy. Okay. There's the formula. We're just going to put it there so we have it for reference. Okay. Take a look at the picture for A. How many bars are there? 7. Okay. So you guys write sum equals 7 over 2. So there's 7 bars, 7 over 2. Okay. What is the height of the first bar? 5. What is the height of the 7th bar? 5. Okay, so this is 10 times 7 is 70 divided by 2 is 35. Okay, are you ready? B. How many bars are in B? 16, right? 16 over 2. What is the height of the first bar? Plus, what is the height of the last bar? B. Sum equals. How many bars are there? 6 over 2. What's the height of the first bar? 228 plus height of the last bar. Okay, last one. Okay, don't let this one trick you. How many bars are there? 32, nice. What is the height of the first bar? And last bar? Okay, now these are all baby problems, um, which is fine. Now we need to do the actual problems. The first thing we're going to do is read the problem. Then we're going to translate. So they're going to be words. We're going to translate their words to symbols. Notice how much room I left. Okay, so this is where it gets spicy. This is where you need to focus. Okay, we're right here. You know that the first term is 18. The last term is 72, and the common difference is 4.5. What is the series? What is the sum? Okay, we're going to start with this. You know the first term is 18. So that means you write first term is 18. Part of this is about translating the words into the symbols. Okay, this says the last term is 72. Now we don't know which one that is, so we're going to put T of n. And the common difference is 4.5. That's the growth, and that means it's D. D is 4.5. Okay, and it says find the series and find the sum. I know that my series is going to start with 18, and then it's going to go up 4.5 each time. But I'm going to grow lazy at some point, and I'm not going to want to list the whole thing. That's fine. It's going to require me to do some extra work in a minute, but I'd rather you do that than list the whole thing out. Okay, now let's try to find the sum. Sum equals n over 2 first term plus last term. What numbers do we know right now that we could plug in to this? Okay, does this make sense so far? I don't know how many numbers there are, but I know the first one is 18 and the last one's 72. Okay, when I have a spot missing in my sum equation, what you want to do is go to the equation. Let me say that again. When a spot is missing, you want to go to the equation every time. So T of n equals. Do you guys want to write your equation in terms of term 0 or term 1? Okay. So that means you start with the growth. Instead of n, you put n minus 1 plus the first term. That's not the choice I would have made there, but that's okay. What? Because Zachary said 1. Okay, now I want to find out what spot this is. I know this is spot 1, spot 2, spot 3. I want to know what spot that is. So what I do is I plug in 72 into T of n. 72 equals 4.5. Well, because this is saying the term. I am going to do that in a minute, but not with this problem. So it turns out that's the 13th number down. I'm going to split my paper over to do B, just so you know. We're only going to do B and D, and then we're done. Skipping C. Yeah, it's spicy for sure. Okay. D. You know that there are 6 terms. The last and smallest term is 21, and the sum is 336. What is the series? Okay, it says, you know there are 6 terms. So on my paper, I'm going to write n equals 6. It says the last and smallest term is 21. So I'm going to write term 6 is 21. And the sum is 336. Sum is 336. And it says find the series. First, I'm going to use the sum equation to see what I can get out of that. And over to the reason I'm doing this is because they gave me the sum. So I need to use the sum equation, see what I can fill in. What can I fill in right now? So 6 over 2. First term plus 21. T of n is 21. Yep. What about this? 336. Does your instinct tell you to distribute or divide? Okay. Let's see. Ooh, I don't know if I can approve. Okay, so I know my first term's 91. I know my last term's 21, but I have to figure out how far apart they are from each other. What do I do when something's missing? Yep. Hold on, not sure yet. Find the equation first. Okay, so D, we don't know. Here's the like general equation for when you're doing it in the first term. And we know our last number is 21. D is what we want to find. That's the growth. N is 6. And the first term is 91. It was enough room. Ah, okay, one more and we're done. D, you know that the third term of an 18-term series is 29, and the terms are increasing by 10. Okay, you know the third term of an 18-term series is 29. Okay, so there's a lot of stuff there. There's 18 terms. You know the third term is 29, and you know they're increasing by 10 each time. Okay, now I'm going to use some common sense and not formulas at first. If my third number is 29, then I can go backwards to get the second one and then go backwards to get the first term. So term 1 is 9. And then we know we want to go out here until we get to the 18th spot because it says there's 18 numbers. Okay, so sum equals 18 over 2, first term plus, we don't know what the last term is. We just know it's in the 18th spot. What do I do when something's missing? With the, yep. Okay. Growth n minus 1 plus the first term. Okay. Now this is the one that you guys were talking about. When I want to find the 18th term, I put 18 in here. And I'm going to find term 18. Okay. I'm listening. Okay. The reason is because, one second. Okay. Hold on. This is the question mark. What I want to find is the term in that spot. So this is saying what number is in the 18th spot? This is saying what spot is number 72 in? Good. Let me go back to here so people can write it down.